Hey everyone, welcome to our next section of food science, Taco 101, talking about matter. So we are going to explore a little more in depth than what we did in our first unit of what matter is and how it relates to food science. So we're going to talk a lot about the different states of matter. We're going to talk about matter in terms of classifying it, whether that be through state or composition, and we'll also talk about bonding. So these are all different things that we are going to chat about here in this section of our unit. Once we're done with matter, we're also going to do some labs in the classroom to help kind of apply some of these concepts. So kind of stick through here and fill out your cheat sheet as you go along. And if you have any questions, feel free to pause, rewind, and reach out. So we are going to go through some of these learning targets for the day. So first, by the end of this, you'll be able to interpret a chemical formula to understand its composition of molecules and compounds. You'll be able to compare and contrast different types of chemical bonds. You'll be able to apply your understanding of matter to evaluate the state or composition of a substance, which should be a review for a lot of us from earlier in this semester. We'll be able to identify the characteristics of physical and chemical changes. We'll be able to connect basic concepts of energy to everyday life and food science. We'll demonstrate the different ways that heat is transferred. And finally, we will describe how the flow of energy connects to state changes in preparing food. So to get started, we're going to talk about chemical formulas. And these are really important foundation to building our understanding of matter. So as we know, molecules are two or more of the same atoms that are joined together in specific geometric arrangements, while compounds, on the other hand, are substances in which two or more elements are chemically combined. The basic unit of any compound is a molecule. For example, sodium combines with chloride to form a sodium chloride or NaCl or table salt. A chemical formula is a combination of symbols of elements making up a compound that represents one molecule or unit of a compound and has the symbol and subscript of numbers of atoms for each element in the compound. So the difference between a subscript and a superscript. So you'll hear me say these a couple of times throughout the rest of the semester. A subscript is like an H2O. The 2 on the bottom, so H2O, that small 2, that is called a subscript, okay? A superscript would be like, let's say in a chemical formula, we have 2 molecules of water. It would be 2H2O, so that big 2 that goes in front. Don't worry about that too much right now. But knowing how to read a chemical formula helps identify the elements that are in a substance. Okay? So H2O, like our example over here. Chemical formulas indicate how atoms are arranged within a molecule as well. Structural formulas for carbon-based compounds are written to show how atoms connect to the carbons. So the chemical formula for acetic acid is C2H4O2. So the structural formula is CH3COOH. We're not going to worry too much about structural versus chemical formulas here because I'm not really going to ask you to draw out structures in this class. That's a little bit more advanced for our college chemistry course here at the school, but it is important to know that there is a difference between how something looks in a chemical formula versus how it would appear in a structural formula. So we are going to stop here for now, and we're going to come back and talk a little bit more about bonds. And those bonds are very important to understand as we move into later on. So thanks for watching.